Okay, so this is the second part of that the lecture we've been working on. This is the word problems. So the first thing you need to do is always draw a picture. Doesn't need to be much detail, just enough to get you across what the question's asking you. Then we're going to write an absolute value function. And then we can use the absolute function to solve for a value. Okay, so the first question is, or this example is at a science museum exhibit, a beam of light originates at a point 10 feet off the floor. It is reflected off a mirror that is 15 feet from the wall the light originates from. How high off the floor on the opposite side of the wall does the light hit if the other side wall is 8 feet from the mirror? Okay, so real quick, if I just draw a rough sketch, I know that the light originates here and it's 10 feet. I know it bounces off of here, and I know this distance from here to here is 15 feet, and you can't see it. So there's that. I know from here to here is 8.5, so the whole distance is going to be 23.5 feet. The question is, what is the measurement of that? Okay. We're going to go ahead and let b equal 1, mostly because we can't move those walls. They're pretty stationary. The only thing I can really do is move this light up and down. So that's why we're going to let b equal 1, because we're thinking it's going to be a vertical stretch and or compression. All right, so draw this line up here. So here's my vertex. So that means that HK is going to have to be 15, 0. All right. Then I'm going to use this point here, 0y, is going to be 0, 10. Okay. So then I'm just going to fill out my equation. All right. So that 10 is my g of x. I don't know a, that's what I'm solving for. X is 0, h is 15, and k is 0, which is super nice for us. Okay. So then 0 just kind of, anything out of 0 is that value there. So then 0 minus 15 is negative 15. Absolute value of negative 15 is 15. 15 times a is 15a. I divide by 15. So I have 10 fifteenths is equal to a, and that reduces to 2/3. All right. So then we're going to go with g of x is equal to 2/3 absolute value of x minus 15. I'm not going to put the plus 0 because I think you know why, because anything added to 0 it's just busy work. Okay. Now, I know I need to know what this point is. I need to know what g of x is. I know this whole distance from here to here has to be 23.5. So I'm going to substitute that value in for x. So I'm going to get g of x is equal to 2/3. Then I'm going to come up to here and go 23.5 minus 15, absolute value. So then I'm going to go g of x is equal to 23.5 minus 15 is, I'm not going to try because I'm tired. 8.5. So the absolute value of 8.5 is 8.5 times by 2/3, and we get 5.67 feet. Okay. All right. Okay, so this is our second example. It says two students are passing a ball back and forth, allowing it to bounce once between them. If one student passes the ball from a height of 1.4 meters and it bounces 3 meters away from the student, where should the second student stand to catch the ball at a height of 1.2 meters? Assume the path of the ball is linear over this short distance. All right, this one I think you could either go A is 1 or B is 1 because you can move, the people can move back and forth. So we're going to let A equal 1 this time so we can work with our B. All right. All right, so we're going to draw a picture. Here's my figure. Yay. Here's my other student. He bounces it here, catches it up there. So I know that this height is 1.4. I know that this distance from here to here is 3. This is the one that's in question. And then I know this height is 1.2. I know that my HK, my vertex, is going to be this point right here. So it's going to be 3, 0. All right. This point is going to be my y-intercept at 0, 1.4. Okay. All right. So then I'm going to scoot that up just a little bit. So we're going to go with g of x. We're going to say a is 1. So I'm going to go 1 over b. And then we're going to have x minus 3 plus 0. I jumped ahead of myself. I apologize, people. G of x is equal to the absolute value of 1 over b, x minus h plus k. All right. G of x is 1.4. We're working for our b. X is 0, h is 3, and then k is 0. All right. So 1.4. 0 minus 3 is 0, negative 3. Negative 3 times 1 is negative 3 over b. Absolute value of that is 3 over b. Okay? So then I'm going to multiply by b. And I'm going to divide by 1.4. So then 3 divided by 1.4 is equal to 2.14. All right. Okay, so now my equation is going to be g of x is equal to 1 over 2.14, and then x minus 3. That would be my equation. All right, now what I need to know is what is this whole distance here, all right, to give me 1.2. I know that g of x is 1.2. I have 1 over 2.14. This whole distance is going to be 3 plus x, and then I'm going to put the minus 3, okay? So 3 plus x is this whole distance, all right? So then we're just going to solve. All right, 3 minus 3, 0. So I'm just going to have x over 2.14, and then I'm going to take, because I wrote the absolute value, now I got to write this out. So 1.2 is equal to x, and then 2.14. I'm going to multiply both sides by that 2.14, and I get 2.57 is equal to x. Now, the whole distance, right? We're not just looking for from here to here, we're looking for the whole distance. We have to add 3 to it, so we get 5.57 meters. That's how long he's got to stay across from each other. Okay, so I'm running a little bit short on time, so I'm just going to give you the 2 examples, the last 2 examples. This one says, Sam is sitting in a boat on a lake. She can get sunburned from the sunlight directly that hits from her directly, and from the sunlight that reflects off of the water. Sunlight reflected off the water at the point 2O and hits Sam at the point 4.5 and 4. I know my picture's backwards, but it makes sense to me. Write a function that describes the path of the sunlight. So 4 is my y. I got that from there. There's my 4.5. That's my x. Minus 2 is my vertex, and that's my 0. So then I solve for it. A is equal to 1.6. So my equation is y is equal to 1.6 times the absolute value of x minus 2. And then the last one was supposed to be like a pool ball question. So imagine that a coordinate grid is placed over the pool table with the origin and the, it's supposed to be down here, lower left corner. The 8 ball is at 4, 5 over 2. And the middle pocket is at 10, 5. Oh, not middle pocket, sorry. The corner pocket up here is at 10, 5. And then the player is going to bank the ball off the side at 6, 0. And then we have to come up with the equation. So the vertex is at 6, 0. So 5 comes from this corner pocket up here. So that's the 5, all right? So A is unknown. 10 is, again, from the corner pocket. And then minus 6 comes from the vertex here. And then plus 0. So you get A is equal to 5 fourths. So your equation is y is equal to 5 fourths x. Oh, sorry, the absolute value of x minus 6.